Just like how we have addition, subtraction, multiplication, and division in normal mathematics. So we have 2 plus 2, 3 minus 2, 3 minus 1, 4 times 5. We also have addition, subtraction, and multiplication, and of course also division in matrix algebra as well. So the division is a little complicated, and there are certain nuances that we need to know if we want to divide one matrix with the other. Essentially, when we talk about division in matrix algebra, we talk about multiplication with an inverse of a particular matrix. So that requires further explanation, which is why we won't be delving into the division part of the operations. But in this video, we will be talking about addition, subtraction, and multiplication. So there are two different types of multiplication in matrix algebra, which is one is scalar multiplication and the other is matrix multiplication, and we will be looking into that in details. But let's first start with the easier one. So that's addition and subtraction. So what do we mean by matrix addition? Essentially, the first thing that we need to know if we want to add two matrices, let's say we have a matrix A and another matrix B. If we need to add these two matrices, we need to make sure that the dimension of the two matrices is exactly the same. That is, both the matrices have the same number of rows, in this case that is m, and both the matrices also have the same number of columns, that is n. That is, these two matrices are of same dimension as I have written here. Now, why is that important? Essentially, when we talk about matrix addition, we add the individual elements of the two matrices. So if we have A, which is whose elements are represented by Aij, where I represents the row of that element and J represents the column of that element, then, and if we have another matrix B, whose elements are represented by Bij, again, I represents the row of that element and J represents the column of that element, then the addition C, the addition of the two elements, which is A plus B, will also have the same dimension as that of the original matrices. So if A and B both have matrices M cross N and M cross N, then the addition of these two matrices will also be of the dimension M cross N. That is why we need to ensure that these two matrices are of the same order. That's one reason. And the other reason is we'll be adding each element, each corresponding element of the A matrix. That is, this element comes from A matrix and this element comes from B matrix. So for each position in C matrix, since we have the same dimension for all these three matrices, that is, all A, B, and C has the dimensions m cross n, that is, the positions or the arrangements of the elements are identical in all three cases. For each position, we'll take the element, the corresponding element of the A matrix and the corresponding element of the B matrix, add them up and get the final result. So let's look at an example. Let's suppose this element, this matrix, is essentially our A matrix, and let's say this matrix is our B matrix. We want to find out the addition of these two matrices. Now let's first check the first condition, whether these two matrices are of the same dimension or not. So here we can see that the matrix has two rows and it also has two columns. That is, the dimension of this matrix is 2 cross 2. Similarly, if we look at the B matrix, we'll see that it has two rows, that is the first row and the second row, and it also has two columns, the first column and the second column. Similar to the A matrix, which also has two rows and two columns. That is, both these two matrices, matrix A and matrix B, has 2 cross 2 as dimensions. Let me write that down. Matrix A has dimension 2 cross 2. Matrix B also has dimension 2 cross 2. Now, suppose that I have made the addition result C. I don't know the elements of the matrix, but from the result that I discussed over here, we can say that the resultant C matrix, which is the addition of A and B, will also be of dimension 2 cross 2. That is, it will be of the same dimension as the original matrices which have been added to get the C matrix. So now we need to figure out these 4 positions or these 4 elements that belong to the C matrix. Now, how do we do that? Let's look at the first position. Let's look at the this position. So let me just mark that here. What we need to do is Corresponding to this position, we need to find out the elements in the A matrix and in the B matrix. So in the A matrix, the first column, first row element is 23. And in the B matrix, the first column, first row element is 5. That is, here, if this is Cij, which is C11, then we need to look at Aij, which is A11, and this will be Bij, which is B11. So we need to add A11 and B11 to get C11. What is that? We'll need to add 23 and 5. Let's look here. This is 23 plus 5, which gives me 28. So the C11 element is the addition of the A11 element from the original A matrix and the B11 element from the original B matrix. Similarly, if we talk about the element C12, this is because it corresponds to the first row, hence 1 subscript first subscript is 1, and the second column, hence the second subscript is 2. So it belongs to the first row and the second column. Correspondingly, in the original two matrices, we'll have the first row and the second column element 46. And in the B matrix, we'll have first row, second column element 2. So we'll add 46 plus 2. 46 plus 2 gives us 48. So we have the C12 element to be 46 plus 2, which is 48. Again, for the C21 element, let me again mark this for you. So this is C21 element. This is because it corresponds to the second row and the first column. So it's second row and first column. Again, we'll go back to the original two matrices and we'll look at the second row, first column. That's 2. And second row, first column, that's 30. So we'll add 2 to 30. 2 plus 30 gives us 32. And finally, for C22 element, which is corresponding to the second row and the second element, the second row and the second element, if we go back to the original matrices A and B, then we'll get A22 element, that is the element corresponding to the second row and second column of A matrix is 90. And if we go back to the B matrix, then we'll look at the second row and the second column and the element will be 5. So we'll add 90 plus 5, which gives us 95. So we essentially add the corresponding elements of the two original matrices to get the individual elements of the resultant matrix. And this concludes matrix addition.